Okay, so and this was brought up last class too, so, and I think it's very important for us to make sure we are all on the same page with this idea. If I were to give you guys, let's just use, we'll use some small numbers here to make things a little bit easier. If I go -3 squared, I need us to understand that that is not the same as -3 squared. They are different, okay? The reason those are different has to do with the fact of what is actually being squared and what is not being squared when we look at the set of parentheses, okay? Remember, the set of parentheses are a grouping symbol, right? Okay? So when I group the, on the left-hand side, the -3, and then I put the power of 2 behind that, that means the -3 is getting squared. So that means we're taking -3 times -3. On the right-hand side there, where there are no grouping symbols, the power of 2 goes only to the thing that's directly behind, which is just the 3. Does that make sense? The negative is not directly in front of the power of 2. So there, what we actually have is the opposite of 3 squared. Well, the opposite of 3 squared, if we think about it that way, what's 3 squared? 9. What's the opposite of that? -9. So this gives me, this one here gives me -3 times -3. This one here really gives me -1 times 3 squared. Does that make sense? Okay. So this one gives me 9. This one gives me -9, and obviously those are not the same. So I just want to make sure that we are all on the same page with this. If I go like -3 squared, obviously that means -3 times -3. It's an even number of negatives, right? So that becomes a +9. I apologize. Does that bother you guys when you see the cursor on the left and it starts writing somewhere else? Yeah? That bothers the crap out of me, right? And it's just because I'm connected to the Wi-Fi a little bit differently. Well, my HDMI in my computer connects to that dangly thing up there in the projector, and it uses the same signal as the Wi-Fi, so they sometimes interrupt each other. All right, there we go. But if I go -3 cubed, that means -3 times -3 times -3. That's an odd number of negatives, right? So that gives me -27. If we go -3 to the 4th, -3, -3, -3, -3, how many negatives? So it's positive. So we have an even number, so it's positive, and we get 81. Okay? Now, this is what math is, and a lot of our rules in algebra are for. If I want to do -3 to the 5th, does anybody want to write -3 out 5 times? No. What if I said -3 to the 51st? Nobody wants to write that out, right? If I ask you, is -3 to the 51st positive or negative, my hopes are you would know that automatically it's negative, right? Because what we're seeing here is that we end up with that amount of terms, and they're all going to be negative. So if we have an odd number of negatives, what's the answer going to be? Negative. And it ends up being -243 if we actually multiply it out. Okay? That is different than this. If I say -3 squared, okay, that means we have a negative. Let me write this way first. We have a negative and then 3 times 3. Because that means 3 squared right there, right? So that's a negative, and then 3 times 3 is 9. Okay? If I have -3 cubed, that's a negative, and then 3 times 3 times 3, so that gives me -27. Okay? Now this negative out front, you can write it that way, that's fine, But a lot of times, if I have like -3 to the 4th, we'll write that, we'll put that negative and we'll say, well, it's -1, and then 3 times 3 times 3 times 3. Does this still say 3 to the 4th? Right? It says 3 to the 4th. If I multiply anything by -1, it turns it into its opposite, right? Well, if I multiply then this by -1, does that turn that into the opposite of 3 to the 4th? Does that make sense to everybody? Yeah. So when you're doing this work, and I have students from all ranges struggle with this. Okay, I have so far, we're 3 weeks into school almost. I've got students that take college, they get college credit in my first and second period classes, and they're still messing some of this stuff up. Okay, it is very, 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 very important for us to understand that when we're squaring something cubed, and whenever we raise it to an exponent, we have to pay attention. Are we raising the negative to the same exponent, or just the value of 3 or whatever? Does that make sense? Okay, so we have to pay attention to that. So that's one thing I think that showed up a little bit in some of the questions in last night's homework. Remember that homework is due tonight. Okay, so if you have not finished that, please do so before 11:59 p.m. And then tomorrow we can kind of do what we've done in the past, where I can look at the questions that we missed the most and talk about those, discuss those. Hopefully it's not an assignment that's going to be real taxing for you if you haven't seen it yet. I haven't finished it yet. What I want to do, so tomorrow, guys, I'm going to give you kind of like what we did last Friday. We'll do a little bit of notes, but then I've got a little quiz prepared for you tomorrow. I'm going to restrict you from using your calculators. And I'll compromise with you. So if I'm going to restrict your calculators, I'm going to make sure that I give you values that you can do pretty easily, okay? Always kind of think, so adding a negative is the same thing as subtracting, right? So whenever I see adding a negative, I always change it to minus, change it to subtraction, and then I always think, okay, if I'm standing on a number line at -5, and I remove 3 from that, I've got to go further to the left. So if I go -5 plus -3, I move further to the left, right? And it put me in -8. Or if I owe somebody $5, I'm -5 to them, and I borrow 3 more, so that's -3. Now I'm indebted $8 to them. So I always try to, when I do that subtraction of negative numbers and adding negative numbers, try to associate it with something that makes maybe a little bit more contextual sense, meaning put money on it or number line on it. That might help. But I'm the quiz tomorrow may incorporate anything over the last couple weeks. Okay, I'm really interested in order of operations and being able to maybe display that we can perform better on the order of operations a week later than what we were able to last week. Does that make sense? The numbers will stay small so that you can do that mental math, but I want to restrict the calculators so that you can demonstrate whether you know order of operations or not, and not letting the calculator do it. That being said, we will finish this chapter hopefully by Tuesday, and right now I'm planning to have a Chapter 1 test next Wednesday. Okay. If anything were to happen, that test will get moved back. It will never get moved forward. Does that make sense? Whenever I give you a week out, say, hey, test coming up in a week, and the day I give you, it will never come before that day. Okay, so the worst thing that could happen is we move it back to Thursday. So right now, plan on Wednesday. The quiz, and whenever I give quizzes, and this is the same for tests, anything we've covered is kind of fair game. Okay, especially in an algebra course, we might be in Chapter 3, but inside Chapter 3, maybe some of the middle parts of problems are incorporating a lot of order of operations. So I might throw in an order of operations question that came from Chapter 1 on Chapter 3 test. Okay, just to allow us to continue to see that repetition. Okay, that's a proven, researched method to help retain information and to develop those skills. Okay, a lot of things I do in terms of constructing homework assignments and tests and stuff like that is based off of research, okay? Based off of data that they've collected and analyzed and state that these are the best practices to increase knowledge in algebra, okay? So that's why I do a lot of things I do. So 1.7, some of the guys you've heard of, okay, but it is one thing that tends to, sometimes even though we've done this before or heard of the distributed property before, it still allows us to stumble or causes us to stumble. So I want to make sure we fully understand what's going on here with the distributed property, okay? I just gave you guys the notes, right? I gave everybody in this group the same thing, right? So I just distributed that paper to everybody in this group, okay? That's all distribute means, to give something out or to pass something out to everybody in the group, okay? Algebraically speaking then, we add a little bit to it. We say if we're going to distribute in mathematics, the process of giving something out is done through multiplication, okay? So when I give, like down there in that example where it says why it works, what we're going to do is we're going to give the 2x the 4. Okay, we're going to take the 4 and we're going to give it to the 2x. Then we're going to take the 4 and we're going to give it to the 3. Does that make sense? But the way we give it, the way we hand it out, is through multiplication. All right, so I'm going to take 4 times the 2x and then 4 times the 3. So the distributive property, or whenever you hear somebody say just distribute, all they're saying there is multiply. That is all they're saying. Okay? Now, guys, this is what I was fearing. I was fearing that if I keep homework open, okay, that we would work on it during class. So let's close our laptops. Thank you. So that's all we mean here. Distribute is a fancy way of saying just multiply the thing that's on the outside by all the individual objects on the inside. Okay? Remember, the parentheses are a symbol for identifying groups, right? So I said I distribute papers to the entire group here. So visually in a mathematical expression, the group is identified by parentheses. So we're going to take that 4, and we're going to give it to everything inside those parentheses. Now, I want to talk about why it works. Okay, and this is algebra in a nutshell. If we were to look at all our algebraic properties and rules that we go throughout the year, this is the reason we have them. If I look at 4 times, like, let's just use 3. 4 times 3. If we go 4 times 3, doesn't that mean 4 plus 4 plus 4? Or some of you might think it means 4 times 3 is 3 plus 3 plus 3 plus 3, right? Is that okay? So multiplication is just repetitive addition. Okay? Well, if I understand that, and I understand the way these two things look, that thing right there is one object, and because of the parentheses, the yellow stuff is one object, and because there's no symbol in between the 4 and the yellow, or the green and the yellow, we know we're multiplying, right? Well, if that's the case, it's the same thing here. Same thing as we did up here. So this turns into actually 2x plus 3 one time, plus 2x plus 3 a second time, plus 2x plus 3 a third time, plus 2x plus 3 a fourth time, right? Okay? Now I'm going to go through and just look at these things. Can I use the commutative property to take all those 2's and rewrite them this way? Maybe I group them that way. And then rewrite the 3's the same way. Does that make sense, everybody? How many x's do we have here then? We have 8 x's. And what does this turn into? 12. Okay? Well, if I do the distributive property, now, when I combine like terms here, and we'll talk about this probably a little bit tomorrow and more on Monday, making this 8x is because of the distributive property again, okay? But hopefully we've already been exposed to that. We understand that these are like terms when you add them that way. But the quick way is to say, I'm going to take that 4 and I'm going to multiply it by that 2x. What's that going to give me? 8x. If I take that 4 and multiply by the remaining objects, what's 4 times 3? 12. And when I say 12, I'm indicating that it's a positive 12, right? When you just say a number and there's no sign out front, you're implying, or it's an understood positive, right? You guys have talked about imperative sentences, correct, in the English class? If I say, do the next problem, I'm talking to you, right? So I could write that you do the next problem. But in an imperative sentence, you're told not to write the you at the beginning, right? Okay? So it's the same idea with positive numbers. A lot of times we just say 12, but it's positive 12. It's plus 12. Okay? Or if 12 were to come first, we can write it this way. Because of the commutative property, can I rewrite it as that? So it's a positive 12. I move that out front, and we now don't write that plus, right? It's an understood positive 12. Okay? And likewise, here, there was no sign for the 8x. But when I move it to the back, I've got to incorporate what that sign for the 8x was. And it was positive because it was understood when it was written as 8x plus 12. So that's the logic of why the distributive property works. Okay? Now, let's talk about why we don't want to use this process over and over and over again. These values can be anything they want to be. So let's say if this number out here was 104. Would you want to write 2x plus 3 out 104 times? No. Okay? That's going to be a task that just drains you. Okay? It takes forever. So when we get algebra rules, there's always going to be like a why it works, why, an individual small case situation like this. But then that doesn't end up being the most efficient way when we use any numbers we want to. So then there's got to be maybe a quicker way. And the quicker way to do that is through multiplication. Okay? So every time that we distribute, all we're doing is taking the number on the outside, multiplying it by all the numbers on the inside, or all the terms on the inside. So this is the distributive property. This is the kind of the way we define it algebraically. There's A, B, and C can be any real numbers they want to be. And all it's saying is if you have that first one, it says A times the quantity B plus C, then all they're doing to get the right-hand side of the equal sign is whatever A is, they multiply it by B. Whatever A is, they multiply it by positive C, and that's where we get AB plus AC. Okay? What we end up, and you see it down here in these examples, and we'll go back up. I just want you to look at these examples. Where is the kind of the A value that definition was given? Is it in front or is it in the back? It's in front of the grouping symbols, right? It's to the left. And that's the way 95% of the time you're going to see it, okay? But I could rewrite this as 2 minus 3x times negative 4, where I put the term that I'm going to multiply through. I could put it back here because multiplication, you can flip them around, right? Multiplication is commutative. So that's what they're showing right here. Okay? The A doesn't have to be out front. And that's one thing that, we see if I give a homework assignment that's got 20 questions on it, 18 of them are probably like that first one. Okay? But the other two have the A on the back, and we get, we haven't done one like this. It's the same thing. Okay? Most of the time you're going to see it written like the top one, but sometimes you might see it back here. All this here is saying is what we talked about yesterday. If I have a positive A times a positive B, isn't that product going to be positive? If I have a positive A then, and I multiply it by a negative C, what's a positive times a negative? It's a negative, right? That's why I'm getting the opposite of AC here. So when we distribute, we could be multiplying negative times positive, and we could be multiplying negative times negative. So we have to keep track of whether it stays negative or it turns into a positive. All right? Let's talk about a quick example here. Let's say I've got, let's go 3, and then let's go 7 plus 3. Okay, and that's using the distributive property. There's no variable terms here, and it doesn't matter. When we do the distributive property, all your things that you're multiplying together could be variable terms, or they could all be numbers, or they could be a mixture of them. Okay? So order of operations, if we go back to section 1.2, order of operations says to do what there first? Parentheses, and that's going to give you what? 10. So then I have 3 times 10, right? And what's 3 times 10 going to give me? 30. So we know through the order of operations that answer should be 30. Okay? Let's do it a different way. Let's use the distributive property, because that's what's being expressed here. We know we should be able to take that times that. What's that give me? 21. And then that times that gives me what? Positive 9. What's 21 plus 9? 30. Is it the same 30 I got using order of operations? All right. So what we need to understand is that when we construct a rule like the distributive property, it should never contradict anything else in mathematics. We've already got some rules built into the first chapter that whenever we add another rule in to all of the mathematics that we do, it will never violate what we already know. Okay? So I'm not going to be able to abide by the order of operations and get 30, and then abide by a true property, the distributive property, and get something different than 30. Does that make sense? You're always going to have to be able, if you can do it 2 ways, get the same answer both ways. Okay? So that's an example using negative positive numbers. Let's do this. Let's go, what if I say negative 2, and then let's go 5 minus 8. Okay? Order of operations, you're going to make this what? What's 5 minus 8? Negative 3. What's negative 2 then times negative 3? 6. Let's see if the distributive property gives me the same answer. What's negative 2 times 5? Negative 10. And now negative 2 times negative 8 gives me positive 16, right? A negative times a negative gives me a positive. What's negative 10 plus 16? 6. The same thing using the order of operations. So that's kind of what we're getting at with those examples there. Okay? Is everybody all right with that? You would get the same thing. Do this in a different color. Let's say this thing here, it's the same as taking 7 plus 3 times 3. That there is what this second line is talking about. You could put that 3 at the end of the grouping symbol. That happens occasionally. A lot of times when that happens, it's because we've gained information maybe from a story problem, and it just, as we work through the story problem, the 7 plus 3 came first, so we wrote that down. And it says, oh, you're going to take that 7 plus 3 and you're going to triple it. So then we write the 3 after it. Does that make sense? That's usually what happens and how that gets developed. But a lot of times you're going to see questions like these 6 here. So why don't you guys take a minute and see what you come up with on number 1. And if you get done with number 1, just before we start, before we reconvene and start talking about the other ones, give you a couple minutes here. Just start working through some of those and see what you come up with. All right, so doing this first one, you're going to take the negative 4 that's out front, right? And you are going to multiply it by the 2. So what's that give you? Negative 8. And then you're going to take the negative 4. Now just be careful here because we're going to multiply it by that thing there, right? So you got to multiply it by negative 3x. So what's negative 4 times negative 3x? 12. It'll be positive 12x, right? Okay. Now, is it okay for you to take your answer and write it as 12x minus 8? Are those the same? Okay, so here's my question. What does x represent? 1. Okay. It's a variable, and it could represent 1, but it could represent 2, could represent 3, could represent a half, right? But it's just a number. Does that make sense? So if I'm questioning whether negative 8 plus 12x, I know that's right. That's what we did. We did the distributive property. We know that's right. And I want to ask myself, is it okay to flip-flop the 2 numbers and write it as 12x minus 8? So what I'm going to do is I'm going to, and this is a game that we can play all the time with all the new rules that we'll learn throughout the year, is I'm going to let x be a number. And I'm going to plug it in here. And when I plug it in there, what's negative 8 plus, 12 times 1 is just going to be 12, right? So what's negative 8 plus 12? 4. Okay. This line here, I'm going to now, because I'm going to see if what I did with the algebra that I used from this line to this line, to see if it was legal algebra, I'm going to use the same x value. What's 12 times 1? 12 minus 8, and I get the same result, 4, right? Okay. If I get the same results, does that tell me that the purple line is the exact same thing as the red line? Yeah. Okay. That will probably 99% of the time, if you are uncertain of whether you can do something algebraically, do it. Do that process, and then take a minute and say, okay, I'm going to go back one line, and I'm going to choose numbers for x or whatever variables I have, and plug in, use order of operations, and get a number back. And then I'm going to go to my new line that I'm questioning. I'm not sure I can do it, and we'll plug in the same variables and see if I get the same result. Does that make sense? If I do, then I'm guaranteed that what I've done was okay. I have equivalent statements. So you can move those around. Now, the reason you can move those around, what allows us with addition, what allows you to move things around? Commutative property. Because think about this. Now, you might say, well, this isn't addition. Well, isn't 12x minus 8 the same thing as this? That make sense? So every time I see subtraction, I can change it into addition. And if it's addition, can't I take that object there and move it out in front? Because with addition, you can move things, right? Order doesn't matter. It's commutative. Okay? What about 3 here? If I distribute, what do I get there? Negative 2? What do I get there? Negative 8. And we'll put our x on there, right? Can I rewrite that as negative 8x minus 2? Yes, I can. I want to show you guys these alternative versions because we might be going through the homework at some point and I write 12x minus 8. I didn't get that. I got negative 8 plus 12x. You got what I got. They're the same thing. Okay? And the sooner we see that and realize the results of the commutative property and associative property, what they can gain, what we gain from them, will allow you to kind of stay on pace a little bit more in our discussions that we have in class. What about let's do this one. What do you get here? What times that number? Negative 16, and then times that. Get positive 20x. Remember, when distributing, and it usually occurs with the second term. That second term is negative 5x. Or if you want to write this way, this might be something that cleans. If you're a person that always messes the signs up, you can rewrite this way.